Welcome to the very first lesson of my 800 challenge series. In this video, we'll tackle two of the toughest digital SAT math questions, the kind you must get right if you're aiming for a perfect score. These problems are adapted from official College Board practice questions with slight modifications. They reflect the style and the difficulty of the last two questions you might see in each module of the real test. Here's how it works. At the start of each question, pause the video, try it on your own, and then follow along as I walk you through the full step-by-step solution. And at the end of today's lesson, I've included two extra practice questions similar to what we solved here. Give them a try to check your understanding. Answers will be posted in the pinned comment. Let's see if you can ace all of them. Let's start with our first example. Two identical rectangular prisms each have a height of 60 centimeters. The base of each prism is a square, and the surface area of each prism is m square centimeters. If prisms are glued together along a square base, the resulting prism has a surface area of 21 over 11 m square centimeters. What is the side length in centimeter of each square base? Each prism has a square base with a side length s and a height of 60 centimeters. A prism has two square faces, 2s squared, and four rectangles, each 60 times s, giving 240s. So m equals 2s squared plus 240s. When we glue them, two square faces disappear, so the new surface area is 2m minus 2s squared. We are told this also equals 21 over 11m. 2m minus 2s squared equals 21 over 11m. Multiply through by 11, 22m minus 22s squared equals 21m, which simplifies to m equals 22s squared. But we also know m equals 2s squared plus 240s. Setting them equal, 22s squared equals 2s squared plus 240s. So 20s squared minus 240s equals 0. Factor 20s times s minus 12 equals 0. Since s can't be 0, so we get s equals 12. Final answer, 12 centimeters, choice C. The next example, in the xy plane, a parabola has vertex 9, -14 and intersects the x-axis at 2 points. If the equation of a parabola is written in the form y equals ax squared plus bx plus c, which of the following could be the value of a plus b plus c? We have a parabola with its vertex at 9, -14 and crosses x-axis at 2 points. Since the vertex is below the x-axis, the parabola must open upward. This tells us a is greater than 0 in the form y equals ax squared plus bx plus c. Next, notice something important. If we plug in x equals 1 into the equation, the value we get from the equation is a plus b plus c. That's exactly what we are looking for. Let's switch to the vertex form y equals a times x minus h squared plus k, where h, k is the vertex. Here, h equals 9 and k equals -14, so our equation becomes y equals a times x minus 9 squared minus 14. Now plug in x equals 1, y equals a times 1 minus 9 squared minus 14. So y equals 64a minus 14. Since a is greater than 0, then the term 60a must be positive number. This means that the value of y, which is 64a minus 14, must be greater than -14. When we checked answer choices, only -12 is greater than -14, so a plus b plus c equals -12. Great job working through today's 800 challenge problems. Now it's your turn. Try the two practice questions at the end of this video. Answers will be posted in the pinned comment. Let's see if you can solve them before checking the solutions.